Hello, hello. Are we live? Yep, that's looking good. Welcome back to the advent of syntran. It's time for day 5. I've heard it through the grapevine that day 5 is difficult, so let's find out. The length of this prompt is mind-boggling. Okay, I'm finally at the end. Okay. I was really worried at first that I was getting flashbacks to like day 19 from last year. Was it day 19? Yeah, day 19 is the only one last year where I didn't get part 1. All of the other problems I at least got part 1, and I usually got part 2. But day 19, like I looked at it and gave up. I was like, this reminds me of one of the other hard days. And it gave you like these blueprints where like ore and clay cost a certain amount of other materials. So I thought this sounded similar at first, but it's not like that. This is just a series of functions. So you have like a seed to soil function and a soil to fertilizer function. And then you have to start with these seeds and map from seed to soil, soil to fertilizer, all the way down through every one of these functions. It's like a chain of composed functions. And then finally, you get to location. And what they want to know is which location do these seeds map to? So that doesn't. It honestly doesn't sound that bad. I heard it through the grapevine that like day 5 was hard. Maybe part 2 is really hard, but part 1. My initial reaction is like it's a really long prompt. The prompt is very verbose, but the concept, unless there's something that I'm missing, the concept is not that difficult. So let's get to it. So we're going to need a function that applies one of these maps. And then I would like to generalize it so that I have one function that applies this map, and then I can use the same syntran function that applies this map. And the only difference is it's going to take this as an input, it's going to take these things as an input, and it's going to take, like, this is the actual input to the function. So 79 is going to be an input. I'm going to feed that into a function that takes 79 and the seed to soil map as some sort of parameter, and then spits out a soil. And then I'm going to plug that back into basically the same function and get a fertilizer. Yeah, so I think I have a picture of how to solve this. Let's see if I can implement it. I think I try not to do this, but I think I need to look at the puzzle prompt on my other monitor while I start working on this code, because it is fairly lengthy. Okay, so this is day 4. Let's get out of day 4 and start working on day 5. Make a directory for day 5, and then push into there. First of all, let's get the test input. There's going to be some parsing work here. Let's save that. Let's see if we can run and just echo the test input. Okay, that's the test input. Let's also save the real input. On the one hand, it's nice that Google Chrome remembers which folder I saved in last, but unfortunately, like, I already have input.txt. Oh, that's an easy way to rename it. Yeah, so now I just want to save it in a different folder. That wasn't so bad. Okay, so let's parse this input. First, we're going to have to parse. I'm probably going to spend like 30 minutes just parsing this. Okay. So, wrong directory. There we go. So we're just echoing the input. Let's take a look at the real input. So I don't have structs. The fact that I don't have structs makes this slightly difficult. I think I can parse the seeds, and I have to parse this thing, and then I have to apply this map immediately. And then I can parse this chunk and then apply that map. So I don't have to hold multiple maps in memory at the same time. I can just hold one map in memory at a time. No, because I don't have growable arrays. Yeah, so like some of these maps, they're 2 lines long, and some maps are 3 lines long or more. And then the test input is crazy. Like some of these are pretty long. What kind of integers do we have here? Ooh. What's the maximum int 32? Oh, come on, man. It's just over the 4-byte integer limit. So I need 64-bit integers for this. I do have 64-bit integers in syntran, but I might have some bugs. Like I only implemented this less than a month ago. And I don't quite have parity between my 32-bit features and my 64-bit features. So this is going to be a real test, because the real input has, I don't remember where it was. Here's another one. Yeah, this is well over the 32-bit integer limit. If I had unsigned ints, maybe I could use unsigned ints. But I don't have unsigned ints. I only have signed integers. So I have to go to 64 bits. I might not be able to do this. But I should be able to at least do the test input, and that's some kind of accomplishment. Okay. So first we have to read the seeds. We're going to split. We're going to read the first line first outside of the loop, because the first line is special. That has the seeds. And then after the seeds, we have a series of maps. So we're going to read the seeds outside of the loop. And then we're going to use that split function that we defined yesterday. Split string with a delimiter of the colon. So that will give us seeds on one side and like the string seeds, and then on the right side it's going to give us a list of numbers. So that list of numbers we then have to split with spaces as a delimiter. One, split that with spaces. Okay, so these are our seeds, but these are actually strings. So I need to parse. Somebody's calling me. I think I'm gonna ignore it. Yeah, so I need to parse these strings to actual integers. I guess, yeah, I would like to have a helper function for that. Also, some functions here. I would like to rename some of these, but I'm not going to do it right now because it's going to break day 4. So at some point when I have time to test this, I'm going to go back and rename these and then test day 4. I'm going to rename this one to, I got a voicemail. I'm going to ignore that. This is really any care equals string, or I don't know if I want it to be string or set, but I want the first thing to be care because this is really only meant to be used with one character. And then, yeah, I think I want to rename this one too. Rather than splitting a string and then calling this new helper function, I think I want to do the string splitting and the parsing all in one function. So it's going to take a string, and it's going to take a delimiter, or a set of delimiters, and that's going to return a vector of integers. I have to be able to work with I64s. So actually it's going to return I64. The real input, or the test input doesn't matter. They all have small integers, but the real input has things that are bigger than the maximum I32. I'm not sure if this function exists. I definitely have parse I32 intrinsic in syntran. I don't know if I have 64, so I might have to switch tasks real quick and add something to the syntran language. What did I do? There we go. Yeah, string vec I. But before I do this, I have to initialize and allocate an integer vector. I'm going to initialize it to all zeros, and it's going to be the same size as the string vector. I've got a lot of unknowns here. I don't know if this is gonna work. Variable undeclared. Oh, I need a colon right here before the return type of the function. Yeah, so this does not exist in syntran. So real quick, I have to add 64-bit integer parsing to syntran. This shouldn't be too hard. This should mostly be just copying and pasting the 32-bit parser. So this is the syntran interpreter course source code. I'm going to take this parse i32 function and copy and paste that same idea for 64-bit integers. That might be about it. I have to test this to make sure that it works. And then later I'll have to go back and add actual unit tests inside the syntran interpreter. It might be that easy. That should be a 64-bit integer. It looks like it works. Maybe I should add some tests right now, because I don't want to add this and then forget to add tests. Will that work? This is actually eval I32. Because I don't want to have to make that right now. We can do some stringly typing. That's a little bit of a hack, but let's see if that passes the test. Tests plural. Should have over 600 tests now. All right, that worked. And let's add one or two real i64 tests that actually require 64-bit integers. So that's definitely a 64-bit integer. And then that's a 64-bit integer. Should be 2 more tests now. I should have 606. Alright, that wasn't too bad. Since I'm doing this in a separate repository, I want to update the version number. So this is now syntran 0.0.28. And we're going to install this as my system default syntran. To rebuild with optimization now, because the last couple builds that I did were debug profiles. Debug is the default profile for FPM. FPM is the Fortran package manager. I only started using this this weekend. It's a relatively new package manager for Fortran. Fortran is like C. It doesn't come with a package manager, but there's this cool group of people who made a package manager for Fortran, which is a lot like Cargo, the package manager for Rust. So it's pretty user-friendly. I think I like it. I was using CMake before. So we should have version .28 now. No. Where the hell did that install? Because it installs there. There we go. There we go. That's the latest and greatest syntran. So now we should be able to parse i64s. Okay. Well, all it did was run. I don't think... I'm not even calling this function yet. So instead of doing the splitting here, let's just do the splitting and the parsing in one shot. And these are the seeds. So seeds equals and now before this was a string type, this is an actual integer i64 type. So this is the type that I want. And that didn't work. Hey, I get a little bit of a stack trace now. I changed my G Fortran compiler version, so I have a stack trace now instead of just like, used to be my whole stack trace was just random hex digits. Now I get like the name of something in the syntran interpreter, so that's marginally more helpful. Oh, I'm splitting the wrong thing, so this should be strs1. Yeah, because it's trying to parse this as an integer, so I'd say that's a bad integer. There we go. We have integers. Those are the seeds. Now we have to start parsing the maps. So we've parsed the seeds. We've parsed the seeds from this line. Now we have to parse one map. We're going to start by parsing one map. Well, this is annoying. I don't have like a rewind or a backspace in Fortran, so I think I have to parse this line, count the number of things until I get a line, like a blank line, which delimits the next map. And then I have to close the file, reopen the file, parse back to here, and then save these things now that I know how many of them there are. So that's going to be a little bit annoying to do, but that's the only way I can do it without adding more features to syntran. Or I could parse the whole file into one big string and then iterate over that instead of iterating through read lines, but it's going to be basically the same idea either way. So we're going to parse this. That's going to be the map name. We're going to save that as a string because then we're going to have to close the file, reopen, and read back to that line after we count the number of lines here. So now we're going to go into this loop. We're going to read a line. I don't even want to loop yet. I'm going to comment the loop out and just see if I can get the first map. So this one should be a blank line. And then we're going to read line again. And this should be the name of the map. Like for the first one, it should say seed to soil map. Okay, so the map name is seed to soil map. That's the first map. Now we're going to have to count the number of following lines until we get a blank line again. I don't have this operator. So I want to read until I hit a blank line, which would basically be like this, but I don't have the not equals operator in syntran, so this won't even parse. Yeah, binary operator, bang equals, cannot be evaluated for strings. So I don't have this operator, but fortunately I can do while not string equals empty string. It's logically equivalent. And this should just give us the 2 lines of integers in the seed to soil map. That doesn't work. I think I just need parentheses. There we go. So we got a line of numbers, then a second line of numbers, and then a blank line, and that's where we ended the loop. Now, this is fun. We're going to have to close the file, reopen it, and read until we get back to the map name. Because I don't have growable vectors, and I don't have a way to go one line back in a file. I just have to go all the way back to the beginning, and then read until I read to the spot that I left off. And while I'm doing this, I want to count how many lines there are. So n line is 0, and every time I read something, we're going to increment that. And then I think it's going to be off by 1 at the end, so correct for that. And then print the number of lines. Okay, so we have 2 lines of numbers here. That's correct. Now we're going to close the file, reopen the file. That'll get us back to the very beginning of the file. And then read until we get to the map name. Then we're going to save these things into a map. We're going to allocate some things for the maps. So every time there's a map, there's a source range and a destination range. Right, like this, I think... Is it source or I think it's destination first, which is a little bit confusing. The first line is the destination range, and then the source range, and then the range length. So we have a destination range. We're going to initialize that to zeros. We have a source range, initialize that to zeros also. And then finally, the length of the ranges. Initialize that to zeros. Now we're going to loop and we're going to read each of these things one line at a time. So for I in range 0 through n line. First, we're going to read a string. Then we're going to split that string into integers. We're going to split that by spaces. And then the dest range is the first one of those things. The source range is the second one, and the length is the last. So at the end of this, we're going to print that table transposed. So this is going to print all of the destination ranges. So that's going to be like the first column. Then we're going to print the second column. And finally, the third column. Oh, F equals open F. That doesn't work. We have to close the file handle and then open the file name. Well, that's not right. So we got the vectors. Or did we? No. Yeah, we got the seed to soil map. No, this isn't right. I think my off by a line. What am I reading? Those are the strings that I wanted to read. So why am I not parsing these into integers? Ints. Why are these not getting saved? Oh, these are 32-bit integers. I need type checking here. This is a syntran bug. Well, really, this to-do note needs to go up here because I'm setting the, when you use the let keyword in syntran, it automatically deduces the type from whatever's on the right-hand side of the equal sign. So this is a 32-bit integer, 0 by default. So that means this is a vector of 32-bit ints. But then in here, I'm setting each member to a 64-bit int. So like it's setting the wrong type, and the type checker doesn't tell me that I'm doing anything wrong here, but it really should. But as long as I know what's happening, and I'm pretty sure this is what's happening, we can just initialize it to the proper type, and then I think this should work. There we go. Wow, that is a terrible bug. If anybody else tries to use this language, they're going to be fucked, because like I knew what happened here because I wrote this, but nobody else would have figured that out. This is a terrible language. Don't try to use this for anything. Okay, so that's what I wanted. Did I read these correctly? So we have 50 and 52. Basically, 50 and 52 are the first column here. Then 98 and 50 is the second column. And then 2 and 48 is the third column. So I have that parsed the way that I want it to. And then when I read the next thing, like the fertilizer to water map, these are going to be vectors of length 4 instead of vectors of length 2. At least that's the idea. But let's see if we can just get the first one. Because for now, I have this outer loop commented out. So I'm just working on the first map. And now, now that we have the seeds and we have the first map, this is the seed to soil map. We can map these seeds to soil values. And then we can... Do they tell us what the soil values should be? Then like what happens to our number 79? Yeah, so for all 4 of these seeds, 79, let me get my other thing in the background. So these are the 4 seeds. 79, 14, 55, and 13. 79 will become soil 81. If we can apply the first map correctly, we should get 81, 14, 57, and 13. So let's see if we can do that. So we're going to take our seeds, and the seeds are going to stay the seeds. Nah, why not? Why not make seeds mutable? We're just going to overwrite the values of seeds every time we apply the map. So we're going to have a map function. So this map function is going to take the seeds, it's going to take the ranges, and then it's going to apply some kind of mapping, and it's going to give me, for the first map is the seed to soil map, so it's going to give me soil, and then I'm just going to overwrite that into the seeds array. So now we have to define this map function. Let me copy and paste that because it has quite a fair number of arguments. And this is going to give me some kind of output. Let's call it vals. I don't put the name there anyway. I just have to put the type. So this is going to be a vector of I64s. I'm gonna make sure that I'm like getting all of the arguments correctly, because who knows, I could have more bugs in syntran. I want to make sure I can at least pass things to a function. So we're gonna allocate a vector of outputs. Yeah. Oh, and I have to put types in everything. So all of these arguments are 64-bit integers, vectors of 64-bit integers. And this line is really long. So let's break that up. Okay, so these things have been passed to the function, and they still have the same values, so that seems good. And right now we're just returning zeros, but it's the same size as the inputs. So that's all good so far. Now you have to apply the map. So how does that work again? Basically, if it's, so this is the destination range, and this is the source range. So if it's within 2, so if it's 98 or 99 of the source range, then we're gonna map it to the corresponding destination range. If it's not within one of these lengths of one of these source ranges, then we're just going to leave the value unchanged. So I think I want to actually not initialize this to zeros. I want to initialize this just to the input seeds. And then if it's not in any of those ranges, the map doesn't do anything. So this will just be seeds. And then instead of zeros, we should just get the inputs back out as the output. There we go. That's the input just echoed back. That's an identity function. It's a map which does nothing. It just takes your inputs and returns them as the outputs. Now we have to iterate through each seed within the seeds, and Yeah, if it's within the range length of the source range, then we're going to map it to the corresponding destination range. So, we're going to iterate through the seeds. And then seed is just seeds I. I'm debugging things and I'm testing and verifying things which you really wouldn't need to test and verify and debug in any sane, well-developed programming language. But I don't trust myself at all. I don't trust the code that I'm writing today, and I don't trust the language syntran itself because I developed it. So I want to make sure that I can pull an integer out of a vector and make sure that, like, this is new. The i64s are a lot newer than the i32s, so I'm not sure if anything is going to work today. In. That's how you do a for loop. Okay, so we're iterating through every one of the seeds. That seems okay. And hopefully these are i64s. There's not really any way to tell. If you go into an interactive syntran session, if you type sci without an input file name, or if you type syntran without an input file name, you can do stuff like this and it just tells you the answer. But you also have this sort of debugging / development tool, which I used a lot in the early days of developing this language. If I do this, it will show me like the syntax tree representation of everything that I type in. So 1 + 2 is a tree. On the left-hand side of the plus operator, the left thing is an i32 with value 1. On the right-hand side of the plus operator is another i32 with value 2. So this will actually show me the types. And then if I do like i64, 0, now I have an i64 type instead of an i32 type. So that's one way that I can see the types, but when I'm running a whole file, there's not really any way for me to know what types of things that I have, because types are just automatically deduced from whatever's on the right-hand side. Okay, now, if this seed is within the len range of a source range, we're going to map it to the corresponding destination range. So we need another loop for j in 0 size destination range. All of these, this is like a parallel arrays data structure. Mr. Pound Sign in my last stream was talking about like parallel arrays data structures. All of these vectors have the same length, so it doesn't really matter which one I put here because they all have the same size. So if the seed is within the length of the source, then I'm going to do something. So if seed minus source j less than len range j, then we're going to do something. We're going to map this seed to some output. I want this to be a while loop because, how do I explain this? I'm going to iterate through each one of these lines, and if it's within a range for this line, I'm going to apply the mapping of this line. But then that might change my number and put it within a range where if I tried to map the second line, it would map it again. But I don't think we want to map things again. I think we only want to map things according to one line. So I want this to be a while loop instead of a for loop. So let j equal 0 while not found and j less than size dst range. At the end of this loop, we're going to increment j. So if we apply one of these mappings, we're going to set found to true, and that's going to break us out of the while loop. And then what do we do? This kind of reminds me of like Unicode character mappings when dealing with font files. So in TTF font files, you have like ranges of Unicode characters, and one font might define like the characters for the Latin alphabet, and another font file might define characters for Arabic glyphs. And like all of those things have different ranges and offsets within the Unicode sequence. So this source and destination and length ranging sort of reminds me of character mappings. So if we're within the length of the source range, then we're just going to map it to the corresponding thing from the destination range. So vec I equals destination range j plus seed minus source range j. And I think that's it. That should apply the mapping. And then we'll break out of the loop. And at the end of all of this, we'll either just have initialized the vector to the seed in the case that this condition is never met, or if it's in one of those ranges, this should map it, and then we'll have the output vector at the end. So let's see if this runs. I got negative numbers. So which ones should I map and which ones should I not map? So 79 should get mapped to 81. That did not happen. 14 should stay the same. 55 should stay the same. Do I have anything? '79 should get mapped to 81. But instead of 81, I got 31, and that's off by 50. So why is that off by 50? So what happens to 79? This should be... that should be the same thing, and that should still be wrong. So I think it's seed. That's even worse. So we're dealing with a second line for at least the first number, 79. Source range starts at 50. So 79 is within this set of numbers. 50, 52. I think I have destination and source backwards. Seed minus destination. No. Why is this so hard? I need to refill my water. So I will be right back. Okay, I'm back. So we want to increment the seed by something. So the output vector is going to be seed plus something. And that something is going to be 52 minus 50. It's going to be the destination range minus the source range. Destination minus source. Destination range minus source. And these parentheses shouldn't do anything. Is that right? No. This is what I had to begin with. How is 79 mapping to 31? Seed is 79. And then dest range minus source range should be 52 minus 50. I have like some kind of weird arithmetic bug in syntran. I think that's what's happening. Why is that negative 48? Negative 48 is what? Minus 98. 98. J. I think it's this part that was wrong. Seed 79. So seed minus source range. Oh, this has to be greater than 0. So if the offset is less than that, and if the offset is greater than 0. Let's write it like that, because then you can tell offset is in the middle of both of these expressions. So offset is between 0 and the range length. There we go. That wasn't so bad. So that's the first map. Is that right? So we get 81, 14, 57, and 13. That's the first map. Now we have to apply all the maps through this whole chain of compositive mapping functions until we get locations. The last thing we're going to do is map humidity to location, and at the end of that are seeds, which we're just overwriting the seeds variable every time we apply a map. Our seeds will become locations. So let's see if we can do that. And then at the end of this that process, we should get 82, 43, 86, and 35. And then we have to find the minimum of those things, which is 35. So can we apply all of these functions? We should just be able to uncomment this outer loop. And I think that should loop through the whole file. And that's exactly right. Okay, so part 1, it's taken me over an hour now, so this wasn't like easier than the last few days, but I don't think part 1 was too much harder either. Maybe part 2 is going to be super difficult. I'll find out. Maybe my code won't even run on the real input because the test input happens to be all 32-bit integers. So if I have some bug that only manifests when my integers are over the max I32 limit, I won't find out until I try to run it on the real input. But before I do that, I have to get the min of these 4 numbers. So, let's, I always call my answer sum because in a lot of the days it is literally a sum. Today it's not really a sum, it's just a minimum. So it's a misnomer, but I'm not going to rename my variable. So sum equals, it's just going to be the first seed. Yeah, and then we're going to iterate and get the min of all the seeds. but we have to do that outside of the loop. And that should be part 1. My code doesn't compile. 132. Need a semicolon. Wow, this line is all fucked up. There's a mismatched parenthesis. I don't have min for 64-bit integers. Do I want to put that in syntran, or do I just want to roll my own min64 right now? So the intrinsic min is nice because it's variadic. It can take more than 2 arguments. It can take 2 or 3 or 4 arguments. I can't do that with like a user-defined function. It has to have a fixed number of arguments. But that'll work. This will be quick and dirty just for today. Min 64, A and B. I don't have ternary if, so like C has this ternary operator with a question mark and a colon. I don't have anything like that. And if B is less than A, ans equals B. I think that's it. Sum also needs to be a 64-bit integer. What is wrong now? Oh. Right. This has to have a return value. Okay, 35. That's the correct answer for the test input. Let's see if this works for the real input. I have no idea. It might not work. So let's toggle this to the real input. This might take a second to run. It's going to print way too much. Didn't take that long to run. Let's find out if this is right. Let's go. So everybody said day 5 was hard. Maybe part 2 is the hard part. That still doesn't sound that bad. This is like a minor variation of part 1. We just have more seeds, but the mapping function is still the same. And honestly, the hard part of this problem was, first of all, parsing. Every day, parsing has been hard. And then the second part is just figuring out this mapping function. So the mapping function doesn't change, so part 2 isn't really much harder than part 1. Lowest location is 46. Oh, okay. So what do the seeds look like? Oh. Okay. Oh. Yeah. Okay. It sounds easy, but if you try to brute force this, you're iterating through like billions of numbers. Yeah. Maybe I don't know how to do this. So this is, wait. Yeah, I think it's quite literally billions of numbers that you have to iterate through if you want to brute force this. So there has to be some sort of clever way to do this, and I don't think I can come up with a clever solution right now. I spoke too soon. I thought this was going to be easy, but I can't iterate over billions of numbers. This is like a cryptographically hard task. Maybe it could be brute forced in a low level language, but this high level language is nowhere near efficient enough to be able to brute force something like that. So you can't work with individual seeds because you're given ranges of seeds. Every pair of numbers is a start seed and a length. So we have to start with 2 billion and have like 100 million seeds after 2 billion. So you have to work with a range and apply a whole range to a mapping function. But a mapping function isn't just going to take one contiguous range and give you out a contiguous range. It could break it up into multiple non-contiguous ranges. So I think this is a problem that you would need like growable vectors to solve, because you don't really know how many ranges you're going to end up with. From one input range, it could get broken up on the first map, and then the next map could break it up into even more ranges. Yeah, so I don't know how to do this without growable arrays, and even then it's still not easy. We could just brute force the test input just to see if we can, because these ranges are not huge. These are 27 different numbers. It's 14 plus 13. I can check 27 different numbers, but I can't do the billions for the real input. I don't know. Let's brute force the test input, and then try to get an idea of how long this will take to run for the real input. So here's part 2. Let's just run part 1 once. Let's go to the test input. And now instead of working with these seeds, we're going to have to expand the seeds. Basically, the inputs, instead of a list of seeds, now the inputs are pairs of numbers. So the first number is the start of a sequence, and the second number is a range. So we want to add up every other number. So we're going to start at 1 and step by 2. And this is just for the brute force solution. This is probably not going to run in any reasonable amount of time for the real input. Everything has to be I64. Okay, N seeds. Where does part 2 start? N seeds is 82. That's not right. How did I get 82? Start at 1, step by 2. How is that stepping by 2? Do I not have for loops with steps? I thought I had this feature. What? That's terrible. And like it doesn't even tell me like there's an unexpected token here. It just parses. What the hell is this even parsing? It just totally ignores my range, or my step. Okay, 27, that's what I wanted. This math might not work. I might have to cast one of these to another integer type. I also have to feed my cat soon. Hey, Kylie, I know you want dinner. And she just stepped on my keyboard. Give me 1 minute, okay? What happened? I was already declared. And K is already declared. Something's not right there. Anyway, I have to feed my cat. I will be right back. Okay, we are back. Why do I have so many things? What is going on? I should get like 27 seeds. I don't know why. My screen is just filled. So one way to just like effectively comment out the rest of this function. I want to print my seeds and stop here. I want to print my seeds and stop here. I can do this by ending the function and then starting a new function and just never calling this dummy function. So effectively I've returned early and commented out the rest of that function. But that's a hack. Oh, well, no. All of my types are like undeclared. Yeah, so that doesn't work. I just have to actually comment this out. How about while false? That'll kill the main loop. I still have so many numbers. So I should have 27 seeds. How do I get so many? I'm working with the test input. So I should have 14 numbers starting at 79, and then I should have 13 numbers starting at 55. So I should have like a total of 27 numbers in my seeds. Why is this part difficult? Like, I should not be struggling with this. Oh well. Did I mess something up when I renamed? I still have 27. I equals 1. How is K 0? K should be getting incremented in here. Why did that loop do nothing? Oh. This is a 64-bit integer, and apparently 64-bit integers don't work for for loops. Can I just cast it? That function doesn't exist. I think I can turn this into a while loop and that might work. This is terrible. Nobody should watch me do this. This is a terrible language. Don't use this. There we go. Okay. Do I have my expanded seeds now? No, what? Why are there so many? What the hell is going on? Seed ranges. Seeds. I don't know what is going on. So I got it right, but then there's like a bunch of junk at the end. Right? Starting at 55. Yeah, so it should start at 55. My cat is playing with a cardboard box in the background. So if you hear like a scratching, scraping noise, that's what that is. What is going on? Why are there so many numbers here? How did seeds change size? That's weird. There's something terribly wrong with 64-bit integers in this language. It's that big from the get-go, but n seeds is 27. Well, that's not great. But this worked. This was like the same idea. NLN. I think the size itself has to be a 32-bit integer. Can I cast? I think this casting function doesn't exist. Yeah, that doesn't exist. Can I make it? I don't think I have any other way to work around this bug. So apparently my arrays have to have a size that's a 32-bit integer. and I have no way to cast this down to a 32-bit integer, because even if, I don't know, can I just initialize it as a 32? Because then I don't know what this operate. I think this should work. Yeah, I think compound plus equals, that should cast it. We're adding a 64-bit integer to it. And this might be unsafe because then we're casting it back down to a 32-bit integer. But it might work. Okay, no. No, it's not defined. Yeah, I need a casting function. I need a way to cast this back down to I32 because that's the only way my array sizes will work. And this is another syntran bug. So we need to go back to syntran and make an I32 function, and that's going to be like we did before where we copied and pasted this to a 64-bit version. Now we're going to take the 64-bit function and copy and paste it to a 32-bit version. So parse converts strings to integers, and then I64 is going to convert something else to an I64. So they're like inverses of each other. They're casting types in different directions. So I32 function we're gonna copy and paste this. I think it makes sense to have these in a consistent order. Doesn't really matter, but I want to have the 32-bit one declared before and set up before the 64-bit version. So that's like the intrinsic declaration, because these are functions that are intrinsic to the syntran language. These functions are built into the syntran language. So this is like the declaration of those functions. And now I have to implement the evaluation of these functions. And that is not here. I have a lot of I32s, so it's hard to find a unique thing to search for. Oh, is that all? Where? Oh, no, I should search for 64 because 64 exists, and now I want to copy and paste that to the 32-bit version. Okay, so now that should be it, that I should have a casting function which converts some other numeric type to 32-bit integers. It could be converting I64 to I32, but it could also cast F32 to I64. You might not really need a function to do that. I haven't until today, but now I need this to convert one integer type to another integer type. That didn't work. Oh. I got a bunch of warnings about tabs, and those are super annoying. W no, hold on. I don't know how to use FPM yet. So there we go. 2I32. Where was that? Line 6461. Yeah, I guess this is useful. Yeah, so it converts any numeric type to an integer. And then if you try to convert some other type to an integer, it will say it can't do that. And this should really be like a parse time error in syntran, but it's an evaluation time error, and it doesn't give you as much context about where the error happened. Okay, so this internal logic is going to be slightly different. We're going to return a 4-byte integer because Fortran talks about their integers in terms of bytes instead of bits. So 32 bits is 4 bytes. And then this is going to be 4. That doesn't have to do anything. Yeah. I think that should be okay. And then the error message is different if you try to convert like a string to an integer. If you want to convert a string to an integer, you have to use parse i32, not i32. This one is strictly for converting one numeric type to another numeric type. Okay, I think it's compiling past that. Let's see if tests pass. And I should add some new tests. Where do I actually test this thing? Is that the only place? I should add some tests that cover converting a float to an i64. But that's tech debt. I'm using the wrong comment character. This is Fortran now. I'll worry about that later, but for now I want to at least copy and paste these ones which convert to i64 and add some tests to i32. No, these are all comparison tests. Let's test some negative numbers. And let's test some multi-digits. This really isn't that comprehensive, but I just want to test more than one thing. I just want to have a few tests. I want to test that the function exists and that like nothing else that I do in the future will break the fact that this function exists. It's not super thorough, but it's better than nothing. So there should be like 610 tests or something now. It doesn't compile. What is wrong with that? Eval. Where did I do that? 597. No, 597 should be okay. What the hell? I didn't touch that line. Oh. Yeah, but these have to be strings. Okay, that didn't work. I think Fortran gave me an error at the wrong line number. Yeah. Well, that was weird. I mean, I do have like, how long is this? I don't know how many lines this is. This is, I can't count them. So from 530 to 604, that's like 74 continued lines. Fortran has some kind of limit on how many times you can continue one line of code, and this is probably like messing it up because it's way too long. But those tests passed now. So we added an I32 casting function. Let's update the version again because I'm exporting this and using it in another repository. And then let's install that for use system-wide. I don't think I'm going to be able to solve part 2, but I think I want to be able to just brute force the test input and then I'll call it a night there. So I want to see if I can get that far. Okay. There we go. Now we have .29. And do we have this I32 casting function now? There we go. Was that 55 for the test input? It says part 1, but it's actually part 2. This is actually part 2 now. Yeah, so part 2, 55. Oh, that's not even right. I think I commented out. Yeah, I commented out the loop or something. No? Yeah. $46. Okay, so we got the right answer for the test input. There's no way this is going to run in any reasonable amount of time for the real input, but let's see if it does. I mean, there's a chance, I guess. Yeah, so how many seeds do we have? We have 2 billion seeds. And is this doing the first mapping function? I don't even know if it started the first mapping function yet. Yeah, so when it starts the mapping function, it should say mapping seeds. And it's not even doing that. I think it's still expanding the seeds. I think it's allocating this array. Yeah, I think not only will it take forever to run, but it's gonna eat up all my memory. So let's watch this. Can this stay on top? No, task manager doesn't want to stay on top. Okay, well, you can see it in the background through the transparent window. So watch this just eat up all my memory. It's rising, it's rising, it's rising, and it's gonna max out at 16 gigs, and then it's gonna grind to a halt. But like, at least I understand how the problem can run on the test input. Yeah, to do this the right way, you can't expand the seeds. You have to work with ranges symbolically, and then when your contiguous range gets split up into non-contiguous ranges, then you have more ranges than you began with. So you have to have a way to deal with that. And yeah, I think this killed my stream. Well, that's not good. Well, I don't know if anybody can hear me right now. Nothing is responding. That's hilarious. I don't even know where my mouse cursor is to be able to kill this thing. Oh, is my audio coming through? Huh. So the stream is still going apparently. This is hilarious. My audio coming through? Wow. The stream is still going, but my computer is so unresponsive that I cannot kill this task. I think I'm gonna have to hard reboot. Huh. So the stream is still going apparently. Well, we had a good run. I have no other way to recover. This is hilarious. Wow. The stream is still going, but my computer is so unresponsive that I cannot kill this task. I think I'm gonna have to hard reboot. Well, we had a good run. I have no other way to recover. This is So that's some progress. It it allocated the array. But it's not going to get much further than this. Oh, I have my cursor. That's some progress. It allocated. And I control alt deleted like 10 minutes ago. So that's finally responding. But it's not going to get much further than this. I don't know, at this point I think I might let it run. I have my cursor. And I control alt deleted like 10 minutes ago. So that's finally Okay, I'll give it until 9 o'clock. I'll give this 2 more minutes, and then I'm gonna forcibly shut down my computer. Okay, I'll give it until 9 o'clock. I'll give this 2 more minutes, and then I'm gonna forcibly shut down my computer. Well, Control-Alt-Delete continues to make progress. Maybe I'll cancel that. Okay, I'm canceling Control-Alt-Delete. 2 billion. All right, we're back, I guess. We're printing a bunch of numbers. There was a network error. This must break the stream, right? But we're just expanding the seeds array. We're back, I guess. Can I switch? Yeah, so when it's printing J, we're printing a bunch of numbers. It is expanding the seeds array. And we're at 3 million out of about 2 billion. So this is 1/1000th of the way done, just initializing the seeds array, and then we have to apply a bunch of mapping functions. So this is never gonna finish. Yeah, I might as well kill it and I guess commit the code. Yeah, let's So this should still run on the test input. Yeah, 46. I don't know if I want to risk opening Chrome right now, because that's going to have to swap a bunch more memory from the disk. It's not worth waiting for this. So it's going to do at least 16 gigabytes just for the initialized seed array, and then it's probably going to do double that every time we call the mapping function, because the mapping function takes the seeds as the input, and then it also has a temp output array, which is the same size as the input. So you better have that much RAM if you even want to start running this thing, otherwise it's going to grind your system to a halt like you just saw it do with me. Can I minimize this window? Come on, man. on the real input, but the test input is runnable. The test input is a workable size. But you have to have some way of working with ranges instead of explicitly working with like 2 billion numbers for part 2. For part 1, it's fine. You don't have that many seeds, so it's not a problem. But yeah, I'm just going to commit this, and I'm never going to solve this. We've got 25 days of this stuff, so if I spend time trying to get day 5 done perfectly, I'll never catch up and do day 6 and 7 and so on. So I'm just gonna call it on day 5. That's okay, because eventually I'm gonna get something that's impossible to do in syntran. I can remove this. And brute force part 2 is included, but that's probably never gonna run. Yeah. How did I end up with a second Chrome? So let's make sure that code pushed. And then I'm gonna end it for today. I wonder if Bad Cop was able to do this in Bash. If anybody could do this in Bash, that's very impressive. Alright, yeah, that's it for today. We added some helper functions. We added parse i64 delimiter. I might add a copy of this function that works on i32s, because that could be helpful. It would have been helpful yesterday, just a little bit. It just could have saved me like a couple lines. But yeah, that's it for today. I will catch you next time.